Hello and welcome back. In this video lesson, we will be solving equations with more than one variable. If you notice the example that we are given, they ask us to solve for y. Our goal is to isolate y on one side of the equation. In order to do that, we need to remove 5x and the coefficient of 3. Our first step is to subtract 5x on both sides of this equation. When we do that, we're left with 3y is equal to negative 5x plus 15. Our next step in order to get y isolated is to divide every term in the equation by 3. When we do that, on the left side, we have successfully isolated y, which is what we were asked to do. Negative 5x divided by 3 cannot be simplified. Therefore, we're just going to write negative 5/3 times x, and then 15 divided by 3 gives us a positive 5. We do not get a single value for the variable y. Instead, we have an expression, but we have completed the task at which we were asked to do. They simply wanted us to solve for y. Here, y is equal to negative 5/3 x plus 5. In the second example, they're asking us to solve for x. If you notice in this equation, we have parentheses and a negative 2 directly outside of those parentheses. Therefore, we need to use the distributive property. I'm going to rewrite this equation just to give myself a little bit more room. We need to distribute a negative 2 to every term inside of the parentheses. When we do that, we get 6 minus 2y plus 6x is equal to 4x. Now, I don't have any like terms on the same side of the equation, so I want to begin moving. If I move this positive 6x to the other side of the equation, I've combined my like terms onto the same side of the equation, and I don't have to worry about the 6 or the negative 2y. So I want to subtract 6x on both sides. I now have an equation that reads 6 minus 2y is equal to negative 2x. My last step in order to isolate x would be to divide every term in the equation by a negative 2. So I now have an equation that reads negative 3 plus y is equal to x. Don't forget here that you are dividing a negative 2y by a negative 2. I have done what they asked. I isolated x. I have x is equal to y plus a negative 3 if I were to read this backwards. In our last example, we're asked to solve for x again. If you notice, we have x and y on both sides of the equation. We also have parentheses, which means we need to use the distributive property. The first thing we want to distribute is the 4 to everything inside of the parentheses. So I want to multiply 4 to x and 4 to negative 3y. This gives me 4x minus 12y equals x minus 6y. Now we want to collect like terms on each side of the equation. Since we're being asked to solve for x, I'm going to remove the x on the right side of the equation, move it over here to the left. This way I'm also dealing with a positive term as opposed to a negative. I get 3x minus 12y is equal to negative 6y. Don't forget about that negative sign in front of the 6. The next thing I want to do is move this negative 12y over to the right side of the equation. In order to move that whole term, I want to add 12y. I'm going to do this to both sides of the equation. I now have an equation that reads 3x is equal to 6y. And my last step, in order to isolate x, I want to divide every term by a positive 3. I now have x is equal to 2y. And there's my answer. I've solved for x. I've isolated it alone on one side of the equation. X is equal to 2y. Thank you for watching, and I hope you've learned something.